Okay, once again, my name is Bill Arnold, and I'm our Senior Director of Alumni and Family Engagement here at Alma College. Welcome to our February edition of Tartan Talks webinar series. It's my pleasure that we will have Dr. Jennifer Vranish as our speaker today. Before we get into the webinar, I just want to again run over some details. We're going to take about 15 or 20 minutes to present the content. During that time, if you have any questions for clarification, use the text chat feature. Again, if you scroll over your screen, if you're on a computer or tablet and you see the window that shows the slides, if you scroll over that, you'll see a menu at the bottom of the screen. There's a piece that says chat with a little chat bubble. If you click on that, that'll open up a text chat window, and you can enter a message in there. You can send it to the whole group, or you can send that directly to me, and then I will ask that, pose that question to Dr. Vranish. So if it's for clarification purposes over something that she's covering at that moment, you can ask it at that time. Otherwise, for more of discussion types of questions, we're going to wait and do those at the end of the presentation. That will allow us to get through the content. So that's kind of how we'll handle our questions and answers today. Again, we're going to ask that everyone keep their microphones muted during the presentation. That just helps us keep the background noise and feedback types of things in the system to a minimum and allows everyone to hear the presentation better. Again, if you have any questions as we go along, feel free to send me a text message in that chat feature. Also want to mention that this is being recorded today, and we will share the recording with you all as participants once we have it processed and edited and scaled down to the right version. And then we'll also post that on our Tartan Talks website at the college. So without further ado, I'm going to introduce Dr. Jennifer Vranish, who is an assistant professor here in integrative physiology and health science. Dr. Vranish joined Alma just this past fall in 2018 after completing her PhD in physiological sciences at the University of Arizona and doing some postdoctoral training at the University of Texas at Arlington. She is an expert in the area of cardiovascular and respiratory physiology. So it's a great pleasure to have her joining us today and agreeing to do this webinar series. So Dr. Vranish, I will turn it over to you from here and take it away.
Wonderful. Thank you so much, Bill. Thanks for having me, and thank you to those who have tuned in. So today I thought I'd talk a little bit about the work that I did as a postdoctoral fellow at Arlington. And specifically, we were very interested in how the cardiovascular system is affected by physical inactivity or periods of prolonged sitting. And so that's kind of the direction where we're headed. But just to talk about a little background, it's becoming very clear that adults and children really aren't getting enough of the daily recommended guidelines for physical activity. And so according to the Centers for Disease Control, it's actually estimated that only about 1 in 5 adults meets that recommended physical activity requirements per day. And it's also, this problem has translated also to our youth, where we see that less than 3 in 10 high school students gets at least that 60 minutes of daily physical activity every day. And so this translates to some pretty important health outcomes, one of which being an increased risk of diabetes. And so this graph, I'll just kind of walk you through it, just focusing on the left-hand side here. And what we see is that if individuals have at least 150 minutes a week of even just brisk walking, their risk of developing diabetes is greatly lower, anywhere from about 10 to 40% or a 30% average just across these studies. So we see a decreased incidence in diabetes in individuals who are exercising more. Whereas if we flip the scenario and we look at individuals who get for every 2 hours a day of TV viewing that these individuals are undertaking, which we would presume then is correlated with them sitting and not moving much, we see an increased risk of diabetes of approximately 20% in these individuals. And so physical inactivity has been very highly linked in this study and many others to the development of type 2 diabetes. And as it turns out, physical inactivity is also associated with different cardiovascular diseases. So it's estimated that we spend more than half of our time when we're awake in a seated position. And this is more so for people who have, desk jobs and things like that. And this increases individuals' risk for the development of cardiovascular disease. So there's a really neat study that came out of England where they investigated the incidence of myocardial infarction, which is really just a heart attack. And they looked at individuals who worked on those double-decker buses. And so the drivers here in red would be ones that are sitting relatively long periods of time, almost their entire workday. Whereas the conductors are walking around and punching tickets, and so they're not sitting as much throughout the day. And what they see is that those that are sitting for longer periods of time have nearly double the risk of a heart attack at some point in their life. A similar study did some research in women and sort of stratified them in terms of whether they sit for low, medium, or high amounts of time, and then looked at the relative risk of them either having a cardiovascular disease-related death or specifically a myocardial infarction or a heart attack that led to death. And what we can see clearly is that as we increase in sitting time, we increase the risk of these cardiovascular-related deaths. And so these data are strictly correlational, so we have to be a little bit careful about saying that sitting causes cardiovascular disease because that's not quite what they're showing. But the link seems quite clear. And so what we undertook then is some research in order to make this link very clear. And can we measure physical measures of cardiovascular function before and after an individual sits for a period of time? And can we show a link between these inactive behaviors and cardiovascular function? And so that's what mainly I'll be talking about today is we assessed what we call vascular function or blood vessel health using an ultrasound machine. And so some of you may be familiar with an ultrasound machine that looks like this. They get used a lot for looking at babies and obstetrics, but we can use them to measure blood flow. And so here's an example of that probe on the brachial artery, so we can get arm blood flow. Or what I'm going to be talking to you about today is this measurement in the leg. And specifically, we're measuring at the popliteal artery, which is right by the knee there. And we can measure leg blood flow and leg blood vessel function as our measure of vascular health and sort of correlate or relate that back to how sitting might be impacting cardiovascular health. So just a little bit more background before I show you some of the data that I collected. So this graph here is showing essentially blood vessel function. And really just to orient you, if this number is higher, that's usually considered a good thing. And if this number goes down, that's usually a bad thing. And I'm happy to talk if anyone's really curious about how this measure is made, but I just thought I'd keep it really simple. And so we're just looking at this number of blood vessel health or function, and higher is usually a good thing. And what we see here is the pre-sit value up here about 7%. And whereas after a 6-hour period of uninterrupted sitting, this is more than half in terms of function. And so a very clear representation of vascular function, vascular health being impaired by just a single bout of sitting. And so this study was sort of one of the first that our group had done and provided us with a lot of great information. But the interesting thing was that it was done in all young, healthy men. And so data in women were lacking at that point. So I kind of came along and we went ahead and wanted to look at both men and women and how does this sitting impact both populations? And this is an important question. Yes.
A question. You indicate blood vessel function. What is it, just to clarify a little bit, without obviously going too much detail, I guess, what is measured there? What is it being determined of blood vessel function? Is
sure.
Blood flow?
I'm sorry, go ahead, Bill.
No, I was just saying that blood flow, what is it that is measured in that?
Absolutely. So we can measure leg blood flow with that ultrasound machine. And what we do is we do a test that's called flow-mediated dilation, or FMD. And so you essentially put a cuff on the leg and you occlude that artery for a little while. And then when you release it, you get this big increase in blood flow. And so the more healthy blood vessel will get a bigger increase in blood flow in response to that stimulus, whereas a less healthy blood vessel will have a lower response. So that's essentially just a reactive response that a natural healthy blood vessel would have. And so the lower that number indicates to us that that blood vessel function or health is sort of impaired. Does that help with that question? Any other?
Yep, thank you.
Okay, great. So we wanted to look further into the potential difference between men and women. And this is an important question because it turns out that women are typically more sedentary than men during the day. And so what we have here is a graph showing the percentage of the population that gets less than 5,000 steps per day. And we have men here in the black bar and women here in the white bar. And so it appears that women are in this lower category of less than 5,000 steps. And just to give you a reference range, it's recommended that you get at least 10,000 steps a day. So this is quite a sedentary population, and it looks as though women may be more so in this category. And if we kind of flip it then and look at the individuals who get greater than 10,000 steps per day, it appears that men more so than women are within this category. So all of this sort of equates to if they're moving less, if they're getting less steps, that typically means that they're probably lying down or sitting more and therefore are more sedentary. And so whether this sitting can impact their vascular function is an important question. And so that's what we set out to do. And so I thought, let me show you some of that data and what that looks like. So just to orient you here, the first graph I'm showing you is leg blood flow. So that's measured straight at rest, not doing that test of blood vessel health yet. I'll show you that on the next slide. And so this is just regular resting blood flow. And this is men in the blue will always be denoted by blue, and women will be shown in orange. And the time scale here, we have our pre-sit value. That's actually when they're lying down. And then we get them into the seated position. And we take a measure almost immediately, and then every hour for 3 hours. And during that 3 hours, that's an uninterrupted sitting period. They're instructed not to move really at all. And then we move them back to the supine position for that post-seated measure, mainly because that blood vessel health measure, that flow-mediated dilation test, needs to be done in the supine position. So what we see is that both groups have a very clear reduction in leg blood flow immediately upon sitting, and that remains low as we go throughout that 3 hour seated period. And even when you return them to the supine position after all that time, because they haven't been moving, we have very low blood flow. And so another way to kind of represent this is we can look at the change in their calf circumference. And so if their calf circumference increases over this sitting period, that would indicate to us that blood is probably pooling in their legs. So this is an estimate of venous pooling, or pooling of blood in your legs. And so we see that both men and women have a similar increase in the amount of blood that appears to be pooling in their legs. And this is just related to the fact that they're not moving and they're sort of stuck in this seated position. So both of these measures would be our sort of estimate of hemodynamic function or overall blood flow. And it appears that men and women have a very similar response to this sitting challenge of this uninterrupted 3 hour sitting period. But now let's look at how the vascular function measures are made. And so the first one I'm going to show you here is what we call microvascular function. So when we do this test, when we occlude the artery, we actually get two measures out of it. We get one response that we relate to the microvasculature, or our smaller blood vessels. These would be those small ones that are really feeding right into our capillary beds. And then on the next slide, I'll show you the function testing that we get from macrovascular, or large blood vessel function. So right now, we're just focusing on our very small blood vessels, and that's what's depicted here on the y-axis. Again, with men in blue, and now we're looking at the change from pre to post-sit, and we see a significant reduction after that 3 hour sitting period. And it appears pretty similar in women, that we see a similar reduction pre versus post-sitting in our women. And so I've just depicted this graph as the change, if that helps you kind of visualize it. So this is just the change in microvascular function from pre to post sitting. And again, this is a similar, not statistically significant difference between men and women. So they appear to have a similar impact on their microvascular function, or the function of those smaller blood vessels, with that 3-hour sitting challenge. Now let's look at the macrovascular function. Again, that's sort of the first graph I showed you, where it's looking at the larger blood vessels. So we'd be looking at, say, the popliteal artery itself, this big conduit vessel. And so that's what we have here on the y-axis. We see men are significantly reduced, as the first study from Restaino had showed. So we're just sort of repeating those results, which is great, reinforcing those findings. However, it appears that women do not have a significant reduction in this macrovascular function, or the function of their larger blood vessels. And so we can look at that as the change to make that really clear. So again, this is the change in macrovascular function from pre to post sitting. And we see a significant reduction in men with a statistically insignificant reduction in women, and the difference here is quite clear. So it appears that there's a difference between how the larger blood vessels are reacting versus the smaller blood vessels, particularly in women. And so just to summarize what this particular study showed us, this prolonged sitting period of 3 hours results in a reduction in leg blood flow that was actually comparable between men and women. They had a similar resting blood flow response between men and women. Similarly, if we look at that function test of the microvasculature, or our smaller blood vessels, it appears that both groups have a similar reduction in this particular parameter. So no real sex differences between men and women. However, macrovascular function, which is actually our sort of classic measure of vascular health that gets made a lot in the clinic, appears protected in women. So women did not see that significant reduction that the men did. And so maybe there's something about women, perhaps estrogen is usually believed to be protective for vascular health. And so maybe something different is going on there with the women, that they appear to be not as impacted by that prolonged sitting period. So some follow-up questions, and where does this research lead us? What do we think about from here on? And so it's important to kind of link the blood vessel health back to cardiovascular function in general. And so whenever we see an impairment in this blood vessel health, that's clearly linked to serious cardiovascular complications and the development of cardiovascular disease, things such as hypertension and increased incidence of heart attack. So if we see changes in this measure, even on a one-day time scale, that may indicate to us that there's a clear link between physical inactivity and vascular or cardiovascular health. And so some subsequent studies, I didn't show you the data for it, but it turns out that it's really important for you to break up this inactivity with movement. And I think we hear a lot about this now, about making sure we get our steps in and making sure we break up our seating time with, every 15 minutes getting up and moving around. And so our group has subsequently shown that either breaking up inactivity with walking or fidgeting while you're sitting, or in fact, you can heat the foot and that increases blood flow to the leg. So that's kind of a fun study. So anything that increases leg blood flow will protect against these impairments that we see in vascular function. So it's really important to kind of keep blood moving. And so some next questions that we have is where this research is going is, what happens when this is compounded over days and weeks and months and years? So if someone has these kinds of behaviors regularly and they're continuing to sit and their vascular function is impaired over time, how does this eventually turn into cardiovascular disease that we see the higher risk of in these populations who sit more? And these populations who already have cardiovascular disease, how does prolonged sitting impact them where they're already sitting at a lower level? These studies that I just showed you were done in college age individuals who have a really healthy vasculature. So how does someone who's older or has hypertension already, how are they impacted by these bouts of physical inactivity or by sedentary behavior in general? So there's quite a bit that we have yet to discover. It's a really open field, but it's becoming very clear that cardiovascular health is very linked to our physical activity or the lack thereof. So that's all the new stuff I had. I'd love to take any questions you guys have. My contact information is there. You're more than welcome to reach out via email or phone if you have additional questions. And thank you so much for tuning in.
Okay, great. Thanks, Jenny. Again, we can take questions through the chat feature, the text chat feature. If you are on a tablet or computer, if you scroll over the screen, you'll see a chat bubble in the word chat, and you can open that and post a question there if you would like. Jenny, I know you one of the things that I began to think about, and you kind of mentioned this, is breaking up sedentary. You said every 15 minutes. Is that the recommended time to if you're going to be seated for an extended period of time, trying to break every 15 minutes? Was that what I heard you say?
Yeah, I've heard varying things. I think that's one of the recommendations, every maybe 15, 20 minutes. And I've heard as much as an hour. So, but there are some studies that have done similar measures that we have made and show an impairment already at an hour. And we subsequently went on to look at even just 10 minutes, and it looks like leg blood flow is down in as little as 10 minutes. So I'd say, but that vascular function measure is not impaired yet at 10 minutes. So I'd say 15 to 20 minutes feels like a pretty safe zone of keeping it moving, or at least, like I said, fidgeting in your chair, keep it, we kind of harp on people who fidget and bounce their legs because it can be kind of annoying, but it's actually really good for your leg blood flow and keeps the blood flowing. So as long as you're moving in some way, and I think that 15 to 20 minute range would be a really nice thing to kind of keep in mind. Yep.
Okay. There's a question related to, obviously there are some people who are doing standing desks now, or the ability to elevate their desks at least for a portion of the day and standing. Is that similar if they're just at least standing if the blood flow is moving, or is standing in one location still going to inhibit blood flow?
Yeah, great question. And so standing is good as long as you're, when we stand, we tend to kind of shift our weight. And so we're inevitably moving even a little bit if we don't realize it. And so that would be a good, as long as you're sort of moving a little bit, swaying or kind of shifting your weight from foot to foot, that would probably, that should also increase kind of getting the blood out of your legs because you're contracting those skeletal muscles. And in fact, Jaume Padilla at Missouri, who's our collaborator on all of this work, showed that if you stand during that 3-hour period, you don't see those same impairments in vascular function. If somehow you were standing and not moving at all and allowing that blood to pool in the legs, just like we do in the seated position, however, it'd be just as bad as sitting. So it's still kind of this idea of moving in some way, but we inevitably do that when we stand sort of naturally. Otherwise, our legs get really sore if we don't. So yeah, it's a great question. And those standing desks are becoming very popular, and I think for good reason. They appear to be quite a healthy option.
Another question is, if someone works on their feet all day, so either standing or walking or just is on their feet all day, but sits all evening because their legs are tired and maybe their feet are sore, does this have an impact on people in terms of what you know in the research?
Yeah, that's a great question. I don't know that anyone has really done that, and that's kind of where I'd like to take the research, is really looking at realistic scenarios. So if we look at someone who's working during the day on their feet and then they go home, as opposed to someone who works seated at the office, but then they go home and are running around after their little ones and really rarely sit when they go home. And I don't think that much has been done in this area to really look at those realistic scenarios. So that would certainly be something that we can look at in the future. I would imagine that the relationship would still be related to movement. And so the more you can move, the better. Even if when you're sitting at home because you're tired, every now and again, crossing and uncrossing those legs or getting up here and there every 15 to 30 minutes even, just to kind of keep that circulation going is never a bad thing.
Great. Okay, any other questions folks have? Feel free to type them in the chat box. Also, you've got Dr. Vranish's email here, and she's generously agreed to entertain any questions that you may have or that come up. Again, we will be sharing this recording if you want to review it later and follow up on things. After we have it processed, we'll be posting this on elma.edu/Tartan Talks, and you can also find our previous Tartan Talk recordings at that website. So I don't see any other questions coming in at this point. So again, thank you, Jenny, for being with us and taking time to present your research. I think this is very interesting, and appreciate your time to prepare all of this. And thank you all for joining us. We currently don't have our next Tartan Talk scheduled yet, but we will be getting that information out via email and Facebook as soon as we get the date for our next Tartan Talk. So with that, we will wrap it up. Thanks everyone for being here. Thanks again, Dr. Vranish. I appreciate it.
Absolutely. Thank you.